Hey, hello, and welcome to today's GFG problem of the day. So, first of all, let me wish all the viewers a very happy Padwa and happy Diwali. Okay, so let's start with the problem today. So, the problem is kth distance. So, what the problem is saying is we'll be given an unsorted array air and a number k, which is smaller than the size of the array. Find if the array contains duplicates within k distance. Okay, so what we want to find out is whether there exists an element which is occurring again within k distance. So here is k given, right? K given. So we have to find whether there exists an element within k distance to its right. Okay, so here 1, right? Here 1 is repeating again. It's repeating itself again at third position, right? After this one. That is it's within k distance. Okay, it's within k distance, and hence we want to return true. So the element can be anywhere. It could have been here, it could have been here, or it could have been here. Okay, so how can we solve this problem? So first of all, let's see the first approach. Okay, so what we can do is we can have a for loop. Okay, having I equal to 0 to n. Okay, and we can have one variable j, a pointer j. Okay, which will start from the next element of next element. Okay, wherein I points to. Okay, and we'll have a range. Let's say equal to k. Int range equal to k. Then what we can do is we can have a while loop, right? While range is greater than 0 and j is less than n, right? Less than n. And then here we can check if r of I, if r of I equal to r of j. If we find the array, if we find the element, if we find, that means we have, if this condition matches, that means we have found a duplicate element within k distance. Okay, so we have to return true from here. Okay, you have to return true. Okay, else what, like if we, what we want to do is we want to keep on decrementing range until it is 0, right? We want to keep on decrementing range and increment j as well. Okay, so this, so if we find this condition, that means we have found a duplicate. Else what we are going to do, so we'll be having, right? So for each I, for the element at I position, we are going to iterate to the next k elements. Okay, to the next k elements, and we'll check whether I is, whether the element, whether there are any duplicate elements. If no, then we are going to go to the next element again and repeat the same process. Okay, but this is going to take what? This is going to take O of n into k, time complexity. Okay, and space complexity, definitely it is going to be O of 1. Okay, so can we find, so this is O of n into k. Okay, worst case it can be O of n square. So can we find something better? Can you find something better? So let's look. What we can do is 1, 2, 3, 1, 4, and 5, right? So what we can do is we'll take a map, key, and value. Okay, key and value. And this key will contain the element and value will be the index. Okay, so what I'm going to do is we'll start from this element, from the last element. Okay, so we're going to find in this map whether there exists 5. No, first of all, definitely the 5 won't be there. So we'll, what we're going to do, 5 will insert the index 0, 1, 2, 3, 4, and 5, right? So 5 we are going to insert into the let's say, yeah, so 5 is an index, right? So we inserted that. Okay, then we go to the second last element, that is the next element. We can say we're going to check in the map again. No, it is not there. So we are going to ingest 4 and its index 4, right? And its index 4. Again, we go to the next element. We find whether there exists 1 in the map. No, it isn't there. So we're going to insert 1 and its index. Okay, then we will iterate to the 3. We'll find it if it is part of map. No, it is not part of map. So we are going to do what? 3 and ingest 2. Okay, similarly 2, we are going to find the map. We didn't find that. So 2 and what? Its index is 1, 2 and 1. Okay, now we come to this element. We find in the map, yes, it is there, right? Yes, it is there. Yes, this element is there. So what we're going to do is we will take the index. We'll fetch the index. Okay, what is the index? 3. And we'll fetch this particular one's index. What it is? 3 minus 0. 3 minus 0. And we're going to check if it is less than equal to k. Right? If it is less than equal to k. Yes, k is what? 3. K is 3. So yes, we can say since this is within, this is less than or equal to 3. So we can say that this is a duplicate element. This is a duplicate element within k distance. We have found a duplicate element within k distance. Okay, and hence we are going to return true. So this is the intuition behind solving the problem. I hope you have got the intuition. Now let's code. Okay. So before going to the code, I'll request to the subscribers to please subscribe to the channel, like the video. Okay. It will really be it will be a reward to me. Okay. So thank you so much. So let's quickly code. So what I'm going to do? So first I'll show the Java code followed by C++. So integer comma integer map equal to new hash map. Okay. And then int n add dot length. Then let's start as I told, let's start with n minus 1 with the last element. I greater than equal to 0 minus minus. Okay. And then what? What are you going to do? If we find map dot contains key, right? Map dot contains key. Yeah, map dot contains key array of I. Okay, array of I. Okay, then what do you want to do? We want to check if or int x, let's say int x equal to map dot get array of I. So we're getting the index, we're fetching the index, now we're checking if x minus I, right? If it is less than equal to k, then return true, simply return true. Okay, simply return true. I've already explained this. Okay, else what we want to do if we didn't find the element yet, right? If we didn't, then what we anyways you want to ingest map dot put array of I comma I we want to put. Okay, and at last what are we going to do? We are going to return false. Okay, let's compile this. Let's submit it. Okay, the test cases are passed. Okay, so let's quickly, thanks for watching. I hope you have got the solution. Let's quickly see the C++ code as well. Okay, so here, first of all, let me explain the time complexity. Here, it is going to take what? O of n only. Okay, O of n, because we are iterating through this for loop once. Okay, and this considering we are searching in the map, the expected time complexity would be O of 1. Okay, and only thing is space complexity, it is going to be extra, which is O of n. Okay, now let's quickly see the C++ code. Okay, here's the C++ code, unordered map we have taken. Then what? We are finding in the map. Okay, and if we found in the map, we are going to fetch the index and we are going to check if it is less than equal to k. Okay, else we are going to ingest the element and its index, and finally we are going to return false. Okay, so this is the solution. I'll attach the code in the comment section. Okay, thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.